stage will be about the chemistry of baking a cake. Have you ever put a bowl of cake batter into the oven and a little while later you pulled out a fluffy golden cake? It almost feels like magic, but of course, it's actually science. As someone who loves both baking and understanding how things work, I want to break down the chemistry behind baking a cake. Every step of the process, from mixing ingredients to pulling a perfectly risen cake out of the oven, is a series of chemical reactions working together. Today, I'll walk you through what's really happening at each stage. And I'm going to start with mixing the ingredients, then baking, and finally cooling, so that the next time you bake, you'll see it as both an art and a science. First, let's talk about mixing. Every ingredient plays a key role in the chemistry of baking. Flour is the foundation because it contains starch and proteins that form gluten when mixed with water. Too much gluten makes the cake tough, and too little makes it crumbly and fall apart, which is why cake flour creates a softer texture due to its lower protein content. Sugar is not just there to make things sweet. It's also hygroscopic, meaning it pulls in moisture to keep cakes from drying out. Plus, it helps with browning, which we'll get into later. Then we have leavening agents, baking soda and baking powder. They create tiny bubbles of carbon dioxide that make the cake rise. Eggs, on the other hand, they are the multitaskers. They work as both binders and emulsifiers, helping fats and liquids mix smoothly. Their proteins also firm up when heated, and that helps the cake hold its shape. Of course, fats like butter or oil make the cake tender by coating the flour proteins and preventing too much gluten from forming. If you've ever creamed butter and sugar together, you're actually trapping like tiny air pockets that expand when heated, and that gives the cake an extra lift. Once the batter goes into the oven, things really start happening. The gas from baking soda and baking powder expands, creating air pockets that help the cake rise, while steam from the liquid ingredients also contribute to this rising of the cake. Around 150 degrees Fahrenheit, starches in the flour absorb water and start to gel, and it thickens the batter into a more structured form. A little later, around 160 to about 180 degrees Fahrenheit, egg proteins solidify and set the cake structure. Meanwhile, one of the most delicious chemical reactions kicks in around 300 degrees Fahrenheit, and this is called the Maillard reaction. This is when proteins and sugars react to create the deep golden brown color and rich flavors that make baked goods taste so good. At even higher temperatures, the sugar starts to caramelize and it adds sweetness and a little bit of depth to the flavor while also giving it that golden crust. We're not done yet though. Cooling is just as important as baking. Once the cake is out of the oven, the starches continue to set, locking in the structure while moisture redistributes to keep it from drying out. Sugar helps by holding onto the water, which is why cakes stay soft for longer. If you've ever been impatient and cut into a cake too soon, you might notice that it kind of dries up really fast. That's because the steam escapes way too quickly before it has a chance to settle back into the cake. Letting it cool fully makes a huge difference in both texture and flavor. So, as you can see, baking is way more than just following a recipe. It's science in action. From the way leavening agents create rise to how the Maillard reaction brings out flavor, every step is part of a chemical process. The next time you bake, you won't just be a baker, you'll be a scientist in the kitchen, mastering the chemistry behind the perfect dessert.